So me again. Right, so I'll be demonstrating this tool called Authorino. Authorino is an external authorization service, right? And it's one of the building blocks, one of the components of a bigger solution, Kubernetes-native solution for protecting especially APIs called Quadrant. Right? So Quadrant is an under development project. So, but it's still available. It's already available for checking on quadrant.io. And Authorino is one of the components, although it can also be used standalone as a separate thing, like I'll be demonstrating here today, right? So it fits into that. If you're following the previous talk on external authorization, if it's that last scenario where you have the control plane and you are pushing policy definitions to the distributed or satellite services that are deciding and enforcing the authorization rules. Okay, and what I'll be doing here is we'll be protecting an application. It's an API, right? An application that's running on a Kubernetes server. By the way, Authorino is a Kubernetes-native service, so it's meant to run on Kubernetes. So this is suitable for protecting workloads running on Kubernetes as well, most of all. And what we'll be doing is we'll be using Authorino to protect, to secure requests sent to this API, which is called the News Agency API. So it's an API that handles requests for news articles. So this is the specification of the API, right? So you can post and create a news article on a given category, right? You can read all or list all the news articles in the category. You can read one particular news article. You can delete one particular news article from a category, right? So this is the specification of our API. And this is more or less how a news article looks like. It's structured, right? So there's an ID, a title, an auto-generated ID, by the way, a title, a body, auto-generated date, right? An author and user ID, which are attributes that can only be filled using some special headers here and not as part of the payload that you send to the API. Okay. This is the outline of this demonstration, right? So we have we deploy the application with no auth at all. So the application does not implement anything, any of those authentication or authorized functions. It's only the bare functionality of creating news articles, reading, listening, etc. Right? Then we try that application unprotected, right? Then we move to securing that application, and for securing that application, we'll be using this pack of API keys for the authentication, right? So we use a shared secret that whoever tries to consume the API needs to provide a key secret, right? An API secret. And authorization, we will be relying on the Kubernetes RBAC system for representing the authorization. So hopefully some of you are familiar with the Kubernetes RBAC and the whole thing of creating roles in a Kubernetes cluster, role bindings in the Kubernetes cluster, right? If not, I totally recommend checking out, right? So this is very useful to have in your tool set, not only to master Kubernetes, right, and configure the Kubernetes, but also to be able to use that to protect other workloads the same way I'll be showing here, right? We try that API properly protected with that security layer. And if we have time, we extend that and we show all the flexibility aspect, how we can leverage the effect when things are decoupled and detached to modify the rules, okay? So this is the stack, right? So we have the Kubernetes cluster. In the Kubernetes cluster, we have the news API running, right? The news API will be wrapped inside of an Envoy sidecar proxy. So the Envoy is that general purpose proxy that I mentioned, right? And we have an instance of the external authorization service Authorino running inside of the same Kubernetes, right? Some requisites here. Quick lifecycle of the API. So when the API is unprotected, you can send requests. You should expect, if it's a valid request, you should expect a 200 response code. Accepted. Okay, right? When we put the API behind that layer of Envoy plus Authorino, then at first, if you do not tell Authorino that that API exists, Authorino will instruct Envoy to respond with a 404. So the traffic will not hit the API, and Envoy will respond immediately to the client with a response hey, I don't know about the service. But in fact, it's because the authorization service doesn't know. Okay. Then you define the security scheme, the policy rules, right? You let Authorino know about the service. But if you do not provide a proper authentication, then you should expect a 401, which is the proper response code for non-authenticated requests. Okay. The next step here in the life cycle is you get authenticated, so you have proper authentication. But if you don't have the proper permissions, right? And now we're talking about authorization, then you should expect to get a 403 forbidden response code, right? And finally, if you are authenticated and you have the proper permissions, you are back to the state where you started, which is getting an 200. Okay, so this is the life cycle. I already anticipated and ran a couple of steps just to speed up, such as I already deployed the Kubernetes cluster here, so it's running, right? I'm using client to start a containerized Kubernetes cluster in my local environment. I already created a namespace where we will be pushing all the workloads or most of the workloads, right? And I deployed the application. The application is composed of just two pieces. I should have represented in the diagram because there is also a Redis database, because where we are storing all the news articles, right? But it's just that, a deployment, a service, right, exposing that on port 3000, the Redis deployment, and a service for Redis to be used, right? So this is already ready, which I can show here, this terminal window. Yeah, not looking great because of the zoom out, maybe better this way. So this is the entire cluster, right? We hit the namespaces and the pods running here. So you can see you have the news agency namespace, you have the news API, and you have Redis. The news API, notice that there's only one container here, okay? Because it's just a news API. So what we're going to do now is we will expose this application, something that would be done in a different way if this was production environment, right? You would create an ingress, you would have an ingress controller, right? Other way. So it's an OpenShift cluster, a route, or whatever, right? DNS put in place. But for this demo, because this is all localhost, what I'm doing is I'm using this tool or this command from the kubectl CLI, which allows me to expose that port 3000 and direct all the traffic originating in localhost to that particular service, right? We'll be running this in the terminal, okay, exposed. By the way, whenever I click here, it jumps straight to the terminal here. This is the Visual Studio Code, right? And execute that same command here, okay? So now what we're going to do is I will send in, just clear this up, sending a request to the API. So this is the host name of the API. So API.news agency, right? For 3000. And when I request, send a get a request to /tech, that means I'm trying to list all the news article in the tech category, okay? It's completely unprotected, so we should expect a 200 now. We do this, that's precisely what happens, right? So we get a 200, and now currently there is no news article. So this is an empty array. By the way, the response is from this JSON, okay? So let's create one. It's unprotected, so I can send another request, right? And create this up again. So we're going to be posting this payload here. So news article, and we should also expect 200, right? And that's precisely what happens again. So we get a 200. That means that the article was created. It's just replying back with the same article with the ID auto-generated. Okay, for that result. In fact, we can repeat that previous request like this. We can see this in a better picture format, right? So let's start securing our application. So what we're going to do is we'll deploy Authorino, which is currently not there, right? So Authorino comes with this operator. I don't know if you're familiar with Kubernetes operators, but it's basically automation for the work of the control plane, right? The managing the control plane, so deploying stuff to Kubernetes, right? So there is this operator that registers new APIs in Kubernetes, extends the Kubernetes API, and handles all requests for creating and managing Authorino instances. That allows us to request an Authorino instance in this manner here. So we can create a Kubernetes request, Kubernetes custom resource of kind Authorino that basically requests an Authorino instance, right? And we'll be requesting one, in this case, particular for the news agent's namespace. Although it could be cluster-wide, it could be for different namespace, okay? But this is going to be only for the news agency. When you do this, if I jump here back to the watch view, now we should have the news agency. We also have Authorino running. Okay. Now what we're going to do is we're going to inject the envoy sidecar. We're going to wrap the application, the news agency, in the envoy sidecar. So let's first create a config map for the envoy configuration. Nothing much to see here, except that the envoy knows about the news API, so envoy will direct the traffic to the news API, but not before getting the traffic authorized with Authorino. So envoy also knows about Authorino, right? There are some configurations here in envoy that makes that magic to happen. So we need to create this configuration, and we need to patch the news API deployment to inject the sidecar. By the way, these two last steps that I'm running would be a lot easier if we were using Istio here, for example, or other service mesh that has the concept of sidecar embedded. So this would be replaced with only one annotation to the deployment of the news API and done, right? But I wanted to show the one step further and see how things happen. Sure.
Sorry, did we already configure Authorino?
No, not yet. Excellent question. Yes. So no, we only have Authorino running, not configured at all. So Authorino doesn't know about the news API. And we injected the envoy sidecar. And because we did that, it redeployed. So as you can see, now we have two containers running inside of this pod, the news API and the envoy sidecar. Okay. Let me just now rewire the service, because we had a service, right, used to access the news API pointing to port 3000. Now we don't want to export that port anymore, right? So what we want to do is we want to export the envoy port, the port that envoy is listening to, right? So just updating the service, and I will kill that process of the port 4, and then we will open a new one, start a new one, exposing the port 8080, the envoy. Okay. Yeah. Okay. Now, because Authorino doesn't know anything about the service, right, we can try the API lockdown, right? So if you send a request, now I'm just switching to the envoy port, right? If you send the same request as before to list all the news articles in the tech category, because Authorino doesn't know anything, we get a 404 not found. And we have some extra information here that the external authorization reason is the service is not found, right?
So here what's happened is envoy has asked Authorino.
Yes.
And Authorino responded.
And the traffic never hit the news API. Okay.
So this is because Authorino still doesn't know about the news API.
Correct. Correct. So let's do that just now, right? The way to let Authorino know about the news API is by creating another custom resource defined by Authorino, which is the auth config. And so this is, you can think of it as kind of a recipe of auth, a combination of policies that you want to enforce, right? In this case, it's meant for this host name here. So all the requests targeting this host name will be mapped to this security scheme, right? And for verification of the identity, we'll be using, as I said before, API keys, right? The way Authorino works is you represent API keys as Kubernetes secret resources, the resource of kind secret, right? And that's why we have a label selector here. So Authorino will be using this label selector to select the secrets that are mapped to be used as a valid API keys to access this API, right? It could be anything else, but this just for this demo. And a requester should pass the secret API key in the authorization header in the request using the API key prefix, right? For the authorization bit, as I said before, we will be delegating that to a Kubernetes cluster, meaning the Authorino will ask the Kubernetes cluster, hey, should I authorize this request? Is this user authorized to access this API, right? And by this API, I mean, you will be issuing a request to Kubernetes. There's a specific API in Kubernetes for this that checks if the resource called news, right? In this API group, there is some role binding to a role that grants access for this particular user, and the user will be read from this JSON path here, which seems a bit cryptic, but it's not. As I said, The API keys in Authorino are stored as Kubernetes secrets, right? Secret resources. As a Kubernetes resource, it contains a metadata, and in the metadata field, you can use the annotations of that resource to store any metadata that it needs to use. So in this case, we'll be storing the username associated with that API key in the metadata of the secret. So Authorino has access to the secret, it will fetch the username from that. And we use that as the username that you ask Kubernetes, hey, is this does this username has access or to the news resource? So let's apply this alt config. Done. Now we can try the API protected, right? Just clean this up. So if we send a request now missing the API key, because we don't have an API key just yet, right? So we don't have how to authenticate. So if we send a request now Authorino knows about the service, but we're missing the authentication. So we get the 401, right? And with some challenge response headers here that say, hey, you need to authenticate with the API. That's how it works. And by the way, this is by RFC. This is how it's possible, right? So let's create an API key. As I said, API keys in Authorino are stored as Kubernetes secret resources. So we're going to be creating the secret that stores the secret API key. As I said before, we're using the metadata and the annotations to store some additional metadata that we'll be using for our authorization rules, right? Well, let's create this. Created. If we try the application again, now providing the API key, we will hit the second block, right? Which is you don't have authorization, but at least you'll be authenticated. As such, we get a 403 forbidden, right? It's not authorized. So let's grant access to the user, right? Access in this case or permissions are stored in the Kubernetes RBAC, so it follows the rules of Kubernetes RBAC. So the Kubernetes RBAC needs to define roles that represent the level of access, and later you need to bind users or service accounts to those roles, right? So create role bindings.
So what happened before was Envoy asked Authorino, Authorino asked the Kubernetes
That's right.
RBAC system, but that didn't know anything. And that's why there was
Correct. So Kubernetes replied with no permission here, right? And therefore Authorino told Envoy, hey, you should respond with the 401. Okay. By the way, that is the example kind of thing that you may want to cache, depending on the whole many times you repeat this, right? So we're going to do here, we're going to create two roles. One to represent the level access for news writers, right? So people who can send GET and POST requests to news, right? And the other one for news admin, we're basically the same thing plus delete, right? So users bound to this row can only list, read, and create news articles, but they cannot delete, whereas users bound to this other one can do all the same things plus delete, okay? So create the roles. Let's bind one of the users, that user whose API key we created. I don't know if I showed that before, but the secret said username Alice, right? So we're going to bind the user Alice to the row news writer. So we're making Alice a news writer. Okay, done. Let's now repeat that request from before. Example, right? The same one, to read, to list all the news articles. Because now Alice is authenticated with the API key, but also bound to a row that grants permission to read the news articles, we get a 200 and here are the news articles. And this is the first time since we start securing the application that the request effectively hit the API. Okay. So what else can we do? Right. Well, we can create another news article, right? As an authenticated user. Here we are. Right. We can, let me repeat this and read again. So now we have two, right? News articles. Okay. What I'm going to do now is I'm going to try to delete news article, right? So this is only to restore the ID, this first command, to store the ID of the last news article created in a shell variable, right? So I'm just getting the last one. So I can, and here it is, this is the one. So I can try to delete this news article, right? And we're using it. So I send this request, I get a forbidden because Alice cannot delete news articles. Okay. Okay, that covers for external authorization being enforced from the outside, right? And only allowing traffic to go to the application when it should, right? When it's supposed to be at 200, right? So let's move one step forward and let's modify the rules there. Let's use the flexibility we have of managing the rules only by modifying those or in that alt config custom resource, right? That makes possible for us to change the rules without having to recompile our application, redeploy our application, right? Nothing of that. So what we want to do here now is we want to extend access to the API to another set of users. Users that will be represented as Kubernetes service accounts, which is a different type of entity in the Kubernetes environment, right? So while one set of users will continue to use API keys to authenticate, this new set of users will be using another type of authentication token, which are the Kubernetes tokens. Service accounts in Kubernetes, they are issued service account tokens that can be a long-lived one or short-lived one. And Kubernetes also offers an API to verify those tokens. So we are configuring Authorino now to issue another request to Kubernetes to verify the authenticity of those tokens, right, with the Kubernetes cluster. So Authorino will be accepting both types of access tokens here, an API key or a Kubernetes token, right? And it will be verifying tokens that include this audience, which happens to be one of the claims in the tokens, the default one in the case of this cluster. And I'm also using another feature of Authorino here, doing some token normalization. Because when the request comes from an API key, we have one structure to represent the identity, which is a Kubernetes secret. And when it comes from a service account token, we have a different structure, which is the service account token. It would make our lives a lot simpler if we can normalize those two structures. So we know that regardless of the origin or the authentication method that was used, we know that we can trust there will be always a claim called username. So a username, when it's API key, comes from the annotation that I showed before. But when it comes from a Kubernetes token, there's already a claim called sub, which is a short for subject, right? That will be calling here username. So we know that either API key or Kubernetes token, we have username in the identity. So we can issue that other request to Kubernetes for the authorization, referring to the user as identity username. Okay? So let's extend. Basically, that's all I did. I just updated the alt config, right? So now create a service account. See what that. It's going to be called use API user janitor. I will fast forward here and create the row binding this service account to the news admin row, the other row, right? Now, there's another thing that comes with kubectl, which is the possibility to request a token, so we can use the token on request sent from the outside the cluster. This is not the usual way that we use service account tokens. Usual service account tokens are meant for authentication of traffic that happens within the cluster. So-called east-west traffic, right? As opposed to traffic that comes from outside the cluster, north-south traffic, right? But because of this demo, we'll be sending a request using curl from outside the cluster. So we're going to be requesting that token so we can send a request from outside the cluster, right? And I will be storing that token in the access token shell variable. So requesting a token for the service account that we just created. This is the basic for encoded token, right? Which is a JSON web token, like token explained to us in the last talk, right? In fact, we can decode this, right? Access token. And this is how it looks like, right? This is the access token decoded, right? So we can send a request. Now authenticating uses this other authentication method. the service account token, right? So send a request. Authorino will accept the request 200, and we are getting the list of news articles again in the tech category. Yeah, but now it's diffusion, right? What else can you do? I mean, one step further, and we finish. Okay, I mentioned that we have two attributes that can only be filled with using some special HTTP header, right? So it's the author and the user ID that owns a particular news article, right? Those cannot be passed in the payload to the API due to how the API was implemented, right? So they need to be injected in the middle. So what we're going to do is we're going to configure Authorino to do something else after the authorization phase, which is if it's authorized, inject or mutate the request before it hits the API, inject in a request header, an HTTP request header called x.txt of data that creates it's a stringified JSON content with two properties, author and user ID. And it reads the author from one property of the identity, one claim of identity, and the user ID from the other one, right? So basically, this is what I'm doing, right? So for example, if I send a request as Alice, again, right, authenticating using Alice's API key to create a news article. Now we get, for the first time, you may not have noticed before, that we have an author field here. That is because the authorization layer that is aware of the identity, right, injected that information in the request before the API, and therefore the API know who owns this new important data, which, by the way, is in a different category. I think it was in the business category previously, right?
So it's injected in the request, not the response.
Correct.
It's the response of there.
Yeah, very well noticed, because that stands for the response that the authorization service gives back to the proxy. So it's, have in mind that the flow goes, you send a request, the request was intercepted or received by Envoy. Envoy holds that request, sends an request to the authorization service using a gRPC fast connection. The authorization service responds back to Envoy, and then Envoy moves on or rejects the original request.
So
based on that.
with the sidecar approach, this is the way, instead of having everything with JWT like we do with WASP or whatever, that we put claims with whatever one, is to alter this header and put everything there.
That is one way. We could also use the GWT, right? Because in fact, Envoy by default will let the GWT token in this case to be passed forward to the application, because it's still part of the other HTTP header, right?
Yeah, but normally the application shouldn't care about the JWT because
Correct.
it should be agnostic of.
Absolutely correct.
So
Yes.
you rely on the HTTP header that should have everything. that you
Correct.
need.
So this is a way, so you not an alternative to inject data in the request and not have to read the GWT. Although this is only just one way, right? There are other ways to get data injected into the GWT. For example, in the request. Authorino also has support for issuing its own signed JSON Web Token instead of injecting an HTTP request header. So we can issue another one that's maybe it's a shorter one, right, with reduced scope, only with the claims that matter to the application and filter the things that do not matter. So it creates a very tiny JSON Web Token, and the application can decode that one, right? With the benefit that it can trust that one.
Could you possibly drop Envoy support and use Authorino at ingress level?
Excellent question. Well, there are actually two answers to the question. At ingress level, ingress depends on some implementation, right? So you need to install an ingress controller that gives you the actual implementation for ingress. It happens that many implementations will have features that are compatible with a tool such as Authorino, including Envoy-based implementations, right? For example, Istio gives you Contour. There are different examples of tools that provide implementations for ingresses or ingress resources that are based on Envoy, but they don't have to be based on Envoy. Authorino happens to implement Envoy gRPC external authorization protocol. but it also implements a more basic protocol for simple HTTP 1.1 connections. So that means that it can work with any other implementation, other proxy. And including, we do have some use cases for Authorino that have nothing to do with proxy whatsoever. Like there's also a use case for Authorino that's more advanced stuff, but I don't know if you know about the Kubernetes validating webhooks thing. It's a way for the Kubernetes API to validate requests before accepting those. So Authorino is compatible with those, so it can be hooked into those. Yes. Good question. No, that would be an interesting RFE because we relied on the operator pattern. It's fairly easy to manage Authorino instance. So what you need to do is you need to deploy the operator. Deploying the operator can be done in multiple ways, right? It can be done the way I did, which I just applied a set of YAMLs, right? Let's just create the deployment of the Authorino operator. So we have it running here in its own namespace, and it's watching the entire cluster for Authorino custom resources, right? But to deploy the Authorino operator, you can also use operator lifecycle manager. I don't know if you know that too. It's quite usual, especially in OpenShift clusters, right? Which is kind of flavor of Kubernetes. But it can also be installed in bare Kubernetes. It's an easy way to install operators. And it comes with a whole catalog of operators from the community where you can search all sorts of operators and get them installed. So those are the usual ways to get Authorino installed, right? Doesn't have to be. You could create a deployment yourself if you don't want to them managed by operators.
It's a nice idea.
Yeah.
So in most applications, we store user credentials and possible tokens on an application level. Authorino stores username, passwords, and operation credentials with a help with Kubernetes configuration files only.
That is for the use case of API keys, right? So not, I wouldn't say configuration files, but in etcd, it's in the database of Kubernetes because they are stored as secrets. But that is for the API key-based authentication. As you saw, the other authentication method based on Kubernetes token, Authorino doesn't know anything about identity whatsoever, right? Authorino only validates the token, including using an API Kubernetes. Authorino also offers support to other protocols for authentication, such as OpenID Connect that we discussed here, where Authorino will use the OpenID Connect discovery endpoint, which is an endpoint specified by OIDC, allows you to fetch the keys that you need to validate the JSON Web Tokens. So it's another way to authenticate that makes Authorino completely ignorant about the existence of those users and those identities, which is, I think, it's effectively a better way. Or using X509 certificates, right, or TLS certificates. It's another way to authenticate, which relies on some trustworthy issuer that actually issues the identity and manages the identity.
And I don't know if it is Authorino specific or Sidecar specific, but maybe you also be specific on what verbs you allow per endpoint. For example, now you define the global get post.
Yes, right.
Can you fully customize it in the abstraction level, let's say, of the YAML, to say get for this endpoint and post only for this?
Correct.
Admin?
Yes, absolutely. I mean, in this case, we were using Kubernetes RBAC system, right? In the Kubernetes RBAC system, when we created those roles, the roles they ask for verbs, right? I mean, this is optional. It could be all verbs, right? Like a start. So you need to fill something here, but this is just a string. It can be whatever you want, right? It doesn't have to be actual HTTP verbs. We use HTTP verbs here because in the request Authorino will send, in this case, which is here in the alt config, the verb is being read from the method of the request, right? But it didn't have to be this way, right? It didn't even have to be Kubernetes authentication, right?
Okay, so it's fully customized. Here you make use of HTTP name.
Correct. Correct.
Okay.
Yes, correct. Right. There are other fields that I'm not using here for more fine-grained authorization. Other authorization methods. Earlier, I mentioned Open Policy Agent, OPA, which is a very powerful policy engine. Authorino comes with OPA embedded. It embedded an OPA module. That means that you can represent your authorization rule right in an OPA policy here, which gives you a lot more flexibility to do whatever you want, right? Amongst with others, some built-in authorization methods as well that are meant for efficiency performance.
So does this mean that the information which we rely on authenticating user has to be inside the JWT?
In this case, no. In this particular case, it's transparent. In fact, in this version, we were not even using JWT at all, right? In this first version, we were using API keys, which are stored as Kubernetes secrets by a convention here that we adopted. And the authorization is stored as Kubernetes roles and role bindings, right? So no JWT involved at all. In the next iteration where we added the service account tokens, those Kubernetes service account tokens happen to be JWT, right? But even so, Authorino is not even decoding those JWT. It's just using those to send a request to the Kubernetes and say, hey, is this a valid token? And Kubernetes says, yes, it is, right? In fact, it could even be an opaque token. It doesn't have to be a JWT. The only case where it had to be JWT is if we were using another authentication method here, which is neither API key nor Kubernetes authentication, but the OIDC one. That means that it had to be a JSON Web Token.
What level of interoperability someone have? So, for example, I want to create a token for a user for 1 hour. However, I want to create a token that is meant for single users.
Right. I'm sorry, for what? Single
user.
Single users. Right.
For maybe the scenario of 5 times a download. To use it as without verifying.
Right.
Is there any extendable controller in order to change that configuration?
I can think of several ways to implement the things that you mentioned, right? Let's start with the temporary token, right? Depends on the kind of token. If you are using an OIDC token issuer, that is a configuration that we rely in the authentication server, right? The server that is actually issuing the token. You can configure the lifespan of the token there, right? If it's not OIDC, but it's like an API key, that is the kind of thing that usually would go, because API keys are much long-lived authentication tokens, that would be the kind of thing that you do in the authorization phase. So you add another policy here, maybe written in OPA, for example, that checks for the creation timestamp of that Kubernetes secret and ensure that it's within a given timestamp. In fact, I think we even have a user guide in the Authorino repo exactly doing that, I think, right? That is for the short-lived one, right? X509 certificates, the same thing, they have an expiration date, right? For the other part, it goes more or less the same way. I mean, the single usage token, right? Probably in the authorization page, what we would have is you would report this to some data storage. You would say, hey, this has been used already, so revoke. Or you would use the revocation endpoint of that token to make sure it's no longer valid, right? Or you can use in the caching mechanism of Authorino here to do kind of an inverted cache, right? So if it's cached, it means it's been used already, right?
You just mentioned caching, I think, for the first time.
Here, oh, wishes, or I could have shown something then. Yeah, I mean, probably we have another talk, right? So I don't want to take too much, but
Sorry.
yeah, we can take this.
It's very
Yeah.
interesting, yeah, but we can totally discuss everything afterwards.
Yeah, okay. So thank you.
Thank
And by the
you.
way, this is available on GitHub, right? So we'll make sure to share all
You
the.
can share the link on the Slack or,
Thank you. Yeah.
thank you.